Hello and welcome to today's webinar, SigmaNEST Maximize Yield, Quality and Machine Motion in organization of IB-CADDY and Sigma Tech Company. My name is Oliver Marinkovic from IB-CADDY, and with me is Diego Bartolucci, Technical Director at SigmaNEST. In today's webinar, we will start with a short presentation of IB-CADDY company, and then we will continue with introduction of SigmaNEST. In the practical presentation, Diego will show 5 basic steps of SigmaNEST from part import to toolpath generating. IB-CADDY was founded in 1991. Today is present on the 3 locations, of which 2 of them are in Slovenia, with a headquarters in Ljubljana, and in Kamnik, where we have our Educational Technology Center. We also have office in the capital city of Serbia, Belgrade. We provide software solutions in different areas of industry, in the field of for graphic engineering, 3D printing, and 3D scanning. One of the solutions that we will present today is SigmaNEST. SigmaNEST is an advanced nesting solution, which offers a wide range of customization, modular features to get the most out of your manufacturing operations. Using SigmaNEST, you can import parts from any major CAD systems, automatically sort them into tasks by material and machine. Optimize your materials usage and machine motions. Post programs to your profile cutting machines and track your productivity from start to finish. SigmaNEST drives nearly every type of profile cutting, routing, or punching machines to produce premium quality parts while saving valuable material and manpower. CAD integration and intuitive interface and local customer support are all reasons why SigmaNEST is the industry leader with over 21,000 systems installed worldwide. Here we can see some of the machine types such as laser, plasma, oxyfuel machine. Also, we support programming water jet machines and punch and laser combo machines, or only punching machines where we can advantage of the tools turret. Additionally, we also support knife machines and single or multiple spindle machines for cutting wood or composites. With SigmaNEST, you can also create nesting for any kind of machines. The advantage of SigmaNEST is that we have one environment where we can program any of the mentioned machine type, and we are not limited to the machine brand. Also, we create a task for one machine, and with a few clicks, we can change the NC export for other machines from your list. SigmaNEST connects individual manufacturing operations to the entire organization to drive incremental improvements and improve efficiency, regardless of your industry sector. From quoting to production to shipping, SigmaNEST comes packed with a range of features that delivers 5K benefits to your fabrication workflow, also known as 5M. For materials, better nesting and improved in remnant strategy that delivers 5% or more in material gains. For motion, our solution provides more than 20% boost in efficiency due to faster programming and faster cutting paths and shop floor solutions. For manpower, SigmaNEST increases in manpower capability with ergonomic solution, industry-focused software, and process automation. In management, our solution integrates data from all areas of operating, giving you key insight and great yields from your machines. Lastly, SigmaNEST allows you to run all of your machines from one software platform, allowing you to share skills through the factory, therefore increasing flexibility and efficiency. SigmaNEST is more than just a nesting software. It's a platform that connects individual operations to the entire company, streamlining your process from the office to the shop floor and back again. Full integration and automatic part creation with 2D and 3D kit systems, including SolidWorks PDM Professional. Smart inventory management with stock control and remnant tracking. Complete part stock quoting, cost estimation, and searchable part database. Integrated shop floor with load manager and color offload, which provides advanced solution for optimization. Integrates with ERP and MRP business systems for cost control and profitability. SimTrans data translation integrates production process with business operations. Total integration with Sigma MRP for streamlined costing, planning, and tracking. Load manager maintains jobs in a scheduling queue, displaying that the program a number, material type, machine, and estimated runtime. Machines are combined into common machine groups, allowing programs to be assigned or reassigned to any machine in that group. Mixing work orders saves time and material, but also creates the potential for error when unloading and sorting parts. Color offload eliminates confusion by color coding and displaying parts grouped in with the orders to which they belong. For particle presentation, we will have a look at import options of 2D and 3D sheet metal parts from different CAD formats. After we import the parts, we need to 6 and then use them in a work order. When we have parts ready and assigned to work orders, we can start to create our task where we will set machine parameters, distance between parts, and assign sheets from our inventory. After we define, we will see automatic nesting based on the large list of various algorithms, and also possibility to manually modify the nest by moving the parts on the sheet. When the parts are positioned on the sheet, we can start working on the toolpath where we can create it automatically and modify it manually with additional features. Now I will let Diego to show us our practical exams.
Hello everybody, and thank you Oliver for introducing Sigmatech and myself to the crowd. Let me change the projection to my screen really quickly, and so we can start. Okay. Hello everybody again. As Oliver just explained, my name is Diego Bartolucci, and I am the Technical Director for Sigmatech SRL. Today I will show you the SigmaNEST flow from import to reports through the 5 steps you mentioned. First thing, I'm going to start with an empty SigmaNEST workspace. As you can see, the software interface is super friendly and it is designed to be easy and straightforward for new users to learn. There are tabs, there are functional blocks, there are primary and secondary buttons, and each one has its own preview as well. The first step is about geometry. There are different ways to manage geometry in SigmaNEST. It can be drawn or it can be imported. For example, it is possible to use the CAD interface, as I am doing now, to draw new geometry from scratch. I will go on drawing a very simple rectangle given 2 points. Of course, I can do this by freely drawing as I did now, but it is also possible to use coordinates and dimensions as well. There are all the tools like lines, rectangles, arcs, circles, and so on. Alternatively, it is possible to use a preset of standard shapes. There are different standard geometries. We can program and add new parametric geometries as well. Using the standard shapes, you can draw the geometry of your choice just by changing the dimensions, and the drawing will automatically adapt to the new dimensions you input. Lastly, you can decide to import a pre-drawn geometry. Let's clear the workspace to take a deeper look at this. SigmaNEST can import a huge variety of file formats, which I'm going to show right now. There are 2D formats like the DXFs and the DWGs. There are 3D proprietary files generated using SolidWorks, Solid Edge, Creo, Inventor, and so on. And it is also possible to import open 3D formats like the STEP or the IGES as well. For this presentation, I'm going to import a few DXF files. We can grab a few ones from my samples list. These ones here should be okay. SigmaNEST will now open a dialog. We call it the level mapping dialog. This dialog is a powerful tool which allows you to filter out the unwanted entities. You can filter by layers, you can filter by colors, you can filter by line type. In this specific example, I'm going to to select all my 3 DXFs, and I'm going to filter out the tags and the title blocks levels. Now that we introduced and talked about the geometry step, we're going to move to the second step, which is about parts and work orders. As soon as I'll press OK, SigmaNEST will import these 3 geometries, and they will be converted into parts, which is what we are seeing right now. A part is a SigmaNEST object comprehensive of different informations. Of course, there is the original geometry, like in this case, but there are also additional informations like the material, the thickness, and the number to nest at a minimum. Please also note that there is plenty of room here to host the information you need, and also that this dialog can be customized in order to fit your needs. In this example, I changed the part data 1 field to become a next operation field, and I changed its box to become a combo box to hold the next operations like bending, deburring, painting, and shipping. This information will be visible in SigmaNEST during all the stages, during the nesting, the toolpath generation, and on the part itself. And it will be possible to be printed as well. Now I'm going to set some data massively on all my 3 parts at the same time. So I will select all of them, and I will say that they are all, let's say, mild steel, thickness 3. Maybe there are let's say 10 parts each. I also want to assign a work order, and I will call it webinar, and a customer, which can be just SigmaTech SRL. Okay, let's also say that we want them to be done by tomorrow. And notice how just by changing the material, just by assigning a material and a thickness, SigmaNEST already refreshed all the information contained into this box. Here you can see the part area, the part weight, and also the cutting time calculated according to the machine cutting charts. This can be helpful to determine a quote for this part on the fly, and this concept can also be expanded by getting to the dedicated cost tab in order to calculate costs and price at the end. So at this point, I'm going to save all my 3 parts. I want to save them into the work order, and we will then move to the step number 3. During the 3rd step, we will create a new task to load the parts we just created. I'm going to start with an empty workspace again. The parts now are already saved into the work orders list. So here, I want to create a new task. And now I will ask SigmaNEST to give me the complete work order parts list. Okay, in this diagram you see SigmaNEST displays all the parts I need to cut on every work order. And this diagram can be rearranged in terms of contents as well. You can move columns freely, and of course the software remembers this and prompts it for the later usages. You can sort data just by clicking on the columns. You can filter it similarly to what you will do in Microsoft Excel. And you can do groupings as well. For instance, I can decide to group by material and then to nest another group by thickness. The idea is that by looking at the screen, you can get a comprehensive but still very tidy list of what you need to cut. I see, for instance, that I have several mild steel thicknesses to cut. And if I open mild steel thickness 3, I can see my parts, which are these ones here, webinar, and also the other work orders parts with the same material and thickness combination. As you can see, there are different work order names, different deadlines to meet, different customers, and so on. I can decide to select each single work order or each single customer one by one and nest them individually, or I can select all of them and then try to lower the scrap. In this case, I'm going for the latter option. So I will select all of them, press OK, and bring them inside the task. Now, a similar concept of control also applies to the sheets. As you can see here, as we have the work orders list, we also have the sheets list. This list will open my inventory And it will also automatically apply a filter based on material and thickness. So now I will see all the items available in my inventory which can be used for this specific nest. SigmaNEST will show both the prime sheets, like these ones. This is a pack of 44 sheets, 3 meters per 1.5 meters. This is another pack, but it will also show the remnants or the skeletons as well. I can select all the sheets and then let SigmaNEST use the best sheet or the best format for me. Or, as I will do in this specific case, I can pick up a defined sheet and just use that format for all the tasks. After the parts in the sheet, it's time to check the last section, which is the task parameters. At any time, it is possible to change the task parameters such as the part clearance, which is the distance from part to part, or the edge clearance, which is the distance from the edge borders, or the auto nesting type and the other parameters you see in this dialog. In this case, I want to keep everything as it is. There is also an advanced list of parameters which we will see later. I just want to press OK, and I will quickly get to step number 4. Step number 4, it's about the nesting, and the nesting can be calculated both in an automatic and in a manual way. The first thing I see here, the first button I see in this nesting tab is the automatic nesting button, so I'm gonna press it. There are, of course, different nesting algorithm and different strategies available to the user. In this case, SigmaNEST has already been done calculating the nesting solution for these parts. I can quickly check the result by going to this multi-view dialog, so I can get a good idea of the global yield of the global scrap. And as I was mentioning before, there are different possible nesting solutions according, of course, to the yield, but also to the nesting requirements. And one example could be the different work orders I put on my sheet. I can see, changing the colors and switching to a color by work order, that in this case, the nesting is pretty much compressed, but also all the work orders has been mixed together. All the parts have been put together regardless of their woes in order to lower the scrap. Now, this can be good, but I can decide to nest instead with a work order per work order base and still try to keep a good yield maximization, a good material utilization. And I can do this by quickly going to the part parameters and by asking SigmaNEST to group my parts according to a field, which is the work order name. This can be done per work order, per next operation, so I can have all the parts which has to be banded, nested before the parts which are just being cut. This can be done for basically every part data field in SigmaNEST. So let me press OK, and let's try to generate the nesting again. So let's re-nest. Of course, this approach will generate a little bit more scrap, but on the other hand, it will be super easy for the operator to unload these parts for the machine. Also note that the software is taking a little more now to calculate the nest, because as you can see here from this little label, now it is continuously nesting each work order and each group one after the other one. So little by little it will produce the good nesting result, which will also keep all the parts of the same work orders connected together. Okay, so we can go back to the multi-view again and check the results. And you can easily see this by colors. Now all the parts belonging to the same work order are nicely packed together, and the yield is absolutely still okay. So I'm gonna back to the standard coloring now. The interesting concept about this is that we are solving a future job shop issues, which is unloading parts on the machine, just by acting at nesting level. We can, of course, also show and discuss a bit about the manual nesting tools. We can pick up any schema. This one should be okay. And I'm going to the standard view again. SigmaNEST has a full range of manual nesting tools. One thing I would like to point out is that SigmaNEST is not just a fully automatic software. We believe our automatic algorithms can bring several benefits to the business, but we also allow our users to work in a very manual way if they desire to do so. Through the manual nesting tool, we can pick up a part, like I'm doing it now. We can move it on the sheet. We can rotate it using the keyboard or using the mouse. We can then expand these features by mirroring it on both axes, by aligning it. We can then use the bump to make sure our part will stay in the boundaries, will not get neither out of the sheet or over the other parts. So basically, there is plenty of manual tools here, both to nest manually or to change and modify nestings created automatically. The last step I'm going to show you is the generation of the toolpath. So to do so, I'm going to the Nest and See tab. Similarly to the nesting concept, which can be done manually, automatically, or with a mix of the two technologies, we offer the same manual and automatic tools also for the application of the toolpath. As you can see here, we have the manual tools, but we also have the automatic NC feature, which is what I am going to run right now. The automatic NC feature is a kind of a unique feature because it offers both a solution to define a cutting order between the parts and the contours, but also to apply several optimizations. For instance, I can decide to optimize the rapid movement between part to part to reduce the overall global running time of the program. And this can be done by using these minimum 1, 2, or 3 algorithms. But I can also decide to preserve, to reduce the material heating by using a different algorithm, which will jump on the sheet a bit more, but it will provide an adequate heating and a uniform heating of the material. There are other algorithms instead which are intended to preserve the stability. So there is a lot of customizations possible here for the different machines. Along with generating a toolpath, along with generating a cutting sequence, I can also apply different customizations. For instance, I can apply the part avoidance. This algorithm reduces the risk of collisions while improving the head-on movements, so it will result in a faster but also safer program. I can use the profile destruct, which will produce grid-like cuts on the internals to make them fall into the machine bed easily. There is, of course, the opportunity to create the remnant crop. So the remnant, if present, will be saved back to the inventory, as we saw before, in order to be used again on future nests. SigmaNEST can then also apply tabs. There are plenty of different algorithms to generate, to place, and to apply tabs according to the different machines and rules. Or it is possible to fillet the NC path to smoothen the cutting process. I can now press OK to this dialog, and this will apply the technology to all the sheets in my list. Okay, as you can see here, I have a cutting sequence. There are grid-like cuts when needed, tabs when needed, and so on. At this point, it is possible to simulate the NC path. I can just run the simulation. Simulating is absolutely important because by doing so, we will be able to check the machine path before cutting the real program. It is possible, of course, to change the simulation speed and to play with it as needed. It is also possible to generate reports, and I'm going to the Nest in Detail tab and then on the Print Nest button. I will show you a couple reports we have as standard reports, so we can talk a bit. Okay, let's go for the all sheets and let's run the preview. In this case, I have sent to the preview both the layout detail, which is our standard layout report, and a part level report for all the layouts. Please keep in mind that all the reports can be customized to the user's needs. We can add the data, change the display, the orientation, portrait or landscape, and also the report editor is visual. So we also have customers who are making the modifications to report themselves. Everything is pretty much open, and you can link it with other databases. So if you want to print an MRP data from your MRP database to the SigmaNEST report, this is absolutely possible. This is an example of the layout detail report. It lists the drawing and the primary data with the layout graphics. This is just, again, an example. We can customize it. I can close this dialog, and this is another example of the part labels report with barcodes as well. Okay, well, the last operation at this point consists in cutting the real program on the machine. Thank you for your time and for joining this presentation. And Oliver, I am passing the control back to you. Thank you.
Thank you, Diego. SigmaNEST has become a brand in sheet metal fabrication, and such as was recognized by many large multinational companies such as John Deere, Airbus, Boeing, and many others. Okay, I think this is it for today. Thank you to everyone for your time and your attention. So thanks you again,
everybody,
and goodbye.